The universe is a vast and mysterious place, filled with wonders that boggle the mind and stretch the imagination. From the smallest particles to the largest galaxies, every corner of the cosmos holds secrets waiting to be discovered. It is full of wonder and beauty, a tapestry of light and color that has inspired humanity for millennia. The night sky, with its twinkling stars and swirling nebulas, is a constant reminder of the grandeur of the universe. Our sun is a star, one of billions in the Milky Way galaxy. It's a relatively average star, but to us it is the most important one. It is the center of our solar system and the source of all life on Earth. It is a giant ball of hot gas that gives us light and warmth. The sun's energy drives our weather, fuels our plants, and provides the energy that sustains all living things. Without it, life as we know it would not exist. But the sun is not eternal. It has been burning for about 4.6 billion years and has enough fuel to last for another 5 billion years. However, like all stars, it will eventually exhaust its fuel and die. Like all stars, it will eventually die. The process of a star's death is a dramatic and violent one, marked by intense changes and spectacular events. The sun's death will be a spectacular event. It will go through several stages, each more dramatic than the last, culminating in a final explosive end. It will expand to become a red giant, engulfing the inner planets, including Earth. This phase will be marked by the sun swelling to many times its current size, its outer layers stretching out into space. This will mark the end of our planet as we know it. The intense heat and radiation from the expanding sun will strip away Earth's atmosphere and boil its oceans, leaving behind a barren, lifeless rock. But even in death, the sun will give birth to new life. The material ejected from the sun during its final stages will spread out into space, creating new formations and seeding the cosmos with the building blocks of new stars and planets. The material ejected from the sun will form a planetary nebula, a beautiful cloud of gas and dust. These nebulae are some of the most stunning objects in the universe, glowing with the light of the dying star at their center. And at the center of this nebula will be a white dwarf, the sun's dying ember. This small, dense remnant will slowly cool and fade over billions of years, a silent testament to the sun's once grand performance. The sun's story is a reminder that nothing lasts forever. Even the most powerful and enduring objects in the universe have a beginning and an end. But it is also a story of hope. The death of one star can lead to the birth of new stars and new worlds, continuing the cycle of creation and destruction that has shaped the universe for billions of years. Even in the face of our own mortality, we can find solace in the knowledge that the universe is constantly evolving, creating new worlds and new possibilities. The story of our sun is just one chapter in the grand, ever-changing narrative of the cosmos. The sun was born about 4.6 billion years ago. It formed from a giant cloud of gas and dust, called a nebula. The nebula collapsed in on itself, and as it did, it began to spin. The spinning caused the material in the center of the nebula to heat up. Eventually, the temperature and pressure at the center became so great that nuclear fusion began. Nuclear fusion is the process of combining atoms to create new, heavier atoms. This process releases a tremendous amount of energy. The energy released from nuclear fusion is what powers the sun. The sun will continue to fuse hydrogen into helium for another 5 billion years. This is the main sequence stage of a star's life. The sun is in the main sequence stage of its life. During this stage, it fuses hydrogen into helium in its core. This process releases a tremendous amount of energy, which is what powers the sun. The energy from the sun makes life on Earth possible. It provides us with warmth, light and energy for plants to grow. The sun's gravity holds Earth in orbit. This keeps our planet at a habitable distance from the sun. If Earth were too close to the sun, it would be too hot for life to exist. If Earth were too far from the sun, it would be too cold. The sun's magnetic field also protects us from harmful radiation from space. This radiation could strip away our atmosphere and make Earth uninhabitable. In about 5 billion years, the sun will have fused all of the hydrogen in its core into helium. This process, known as nuclear fusion, is what powers the sun and produces the light and heat that we receive on Earth. Over billions of years, the sun has been converting hydrogen into helium in a delicate balance that maintains its current size and temperature. However, once the hydrogen in the core is exhausted, this balance will be disrupted. The core will contract and heat up as it tries to find a new source of fuel. This increase in temperature and pressure will cause the core to become denser and hotter. The intense heat from the contracting core will then cause the outer layers of the sun to expand dramatically. This expansion will be so vast that the Sun's diameter will increase many times over, transforming it into a red giant. The Sun will grow so large that it will engulf the orbits of Mercury, Venus, and possibly even Earth. This means that these planets will be swallowed by the Sun's outer layers, effectively ending any possibility of life on them. As the Sun expands, it will become cooler and redder. This change in color and temperature is due to the outer layers spreading out and cooling down, even as the core remains incredibly hot. This is why it is called a red giant. The Sun will be a massive, cooler and redder version of its current self, dominating the inner solar system with its immense size. The Sun will remain in this red giant phase for about 1 billion years. During this time, it will undergo significant changes, shedding its outer layers and losing a substantial amount of its mass. This mass loss will occur through powerful solar winds and massive ejections of material from the Sun's outer layers. These processes will strip away a significant portion of the Sun's mass, altering the gravitational balance of the solar system. As a result of this mass loss, Earth's orbit will expand. The reduction in the Sun's gravitational pull will cause our planet to move further away from the Sun, changing its position in the solar system. However, even if Earth is not engulfed by the Sun, the intense heat from the red giant will make our planet uninhabitable. The surface temperatures will rise to extreme levels, boiling away the oceans and stripping the atmosphere, leaving Earth a barren, lifeless rock. Section 5. Earth's scorched fate, engulfed or uninhabitable. The fate of Earth as the Sun expands into a red giant is uncertain. One possibility is that Earth will be engulfed by the Sun. If this happens, our planet will be vaporized. The other possibility is that Earth's orbit will expand enough to escape engulfment. However, even if Earth survives being engulfed, it will still be rendered uninhabitable. The intense heat from the red giant will boil away our oceans and melt our mountains. Earth will become a barren and lifeless wasteland. The expansion of the Sun will have catastrophic consequences for all life on Earth. The once life-giving star will become a harbinger of destruction. Section 6. A glimmer of hope, seeking refuge in the cosmos. The Sun's eventual demise presents a significant challenge for humanity's survival. As our home star approaches its twilight years, we must confront the reality that Earth will become uninhabitable. However, amidst this cosmic drama, there is a glimmer of hope. Humanity has the potential to escape Earth's fate and seek refuge among the stars. One option is to colonize other planets within our solar system or beyond. Mars, with its potential for terraforming, and the moons of Jupiter and Saturn with their subsurface oceans offer potential havens for human life. Another possibility is to construct massive space stations or generation ships, self-sustaining vessels capable of interstellar travel to carry humanity to new star systems. These endeavors will require unprecedented technological advancements and global cooperation. Section 7. The Planetary Nebula, a star's final performance. After its red giant phase, the Sun will begin to shed its outer layers of gas. This gas will be ejected into space, forming a beautiful cloud of gas and dust called a planetary nebula. The planetary nebula will be visible for thousands of years before it fades away. The colors of a planetary nebula are determined by the elements that are present in the gas. For example, oxygen emits green light, while nitrogen emits red light. Planetary nebulas are not actually related to planets. They were given this name by early astronomers who thought they looked like planets through their telescopes. The Sun's planetary nebula will be a spectacular sight, but it will be a bittersweet reminder of our star's death. Section 8. The White Dwarf, a stellar corpse. At the center of the planetary nebula will be the Sun's remaining core. This core, which is about the size of Earth, is called a white dwarf. A white dwarf is incredibly dense. A teaspoonful of white dwarf material would weigh as much as a car. White dwarfs are very hot when they are first formed. However, they do not have any internal source of energy. This means that they will slowly cool down over time. Eventually, a white dwarf will cool down enough to become a black dwarf. A black dwarf is a dead star that no longer emits any light or heat. The Sun will become a white dwarf in about 7 billion years. It will then slowly cool down over trillions of years. Section 9. Our Cosmic Legacy. A universe of possibilities, the Sun's final act, a celestial drama billions of years in the making, is a spectacle that has fascinated humanity for generations. This grand finale, where our star will eventually exhaust its nuclear fuel and expand into a red giant, serves as a profound reminder of the impermanence of all things, even stars. As we gaze upon the night sky, we are reminded of the countless stars that have lived and died, each one contributing to the cosmic tapestry. The death of a star transitioning into a supernova is not just an end, but also a beginning, seeding the universe with the elements necessary for new stars and planets to form. Yet in the face of this cosmic inevitability, humanity has the potential to carve its own destiny among the stars. Our journey into space is not just about survival, it is about exploration, discovery, and the unyielding human spirit. The dream of establishing colonies on distant planets, of traveling through the vast expanse of space, is becoming more tangible with each passing day. The quest to ensure our survival, in the face of the sun's demise, will undoubtedly push the boundaries of science, technology, and human ingenuity. Scientists and engineers are working tirelessly to develop the technologies that will enable us to travel to and thrive on other worlds. From advanced propulsion systems to sustainable life support, the challenges are immense, but so are the rewards. It will demand global cooperation and a shared vision for the future of our species. International space agencies, scientists, and engineers from around the world must come together, pooling their knowledge and resources to achieve what no single nation could accomplish alone. This collective effort will be a testament to what humanity can achieve when we work together towards a common goal. As we look to the cosmos, we must carry with us the lessons learned from our time on Earth, striving to create a future where humanity can thrive among the stars. Our experiences on Earth, both our triumphs and our failures, will guide us as we venture into the unknown. We must remember the importance of sustainability, cooperation, and the preservation of our environment, even as we explore new worlds. Striving to create a future where humanity can thrive among the stars, we envision cities on Mars, habitats on distant moons, and spaceships traveling to the far reaches of our galaxy. These dreams are no longer confined to the realm of science fiction. They are becoming achievable goals thanks to the relentless pursuit of knowledge and innovation, a testament to the enduring spirit of exploration and the boundless potential of the human race. The sight of astronauts planting a flag on an alien world, of spacecraft exploring new galaxies, and of humans gazing at the stars from the surface of another planet will be a powerful symbol of our collective achievements and aspirations. The universe awaits, filled with both challenges and possibilities. Each new discovery, each new frontier presents us with opportunities to learn, to grow, and to push the boundaries of what we thought possible. The vastness of space is both daunting and inspiring, a reminder of how much there is still to explore, and it is up to us to write the next chapter in our cosmic story. As we venture into the unknown, we carry with us the hopes and dreams of all humanity. The story of our journey into space is just beginning, and it is a story that will be written by the generations to come. The universe is vast, and our potential is limitless. Together we will explore, discover, and thrive among the stars.